You know, it's kind of wild to think that so much of the AI we see today, I'm talking facial recognition, chatbots, the whole shebang, can be traced back to a single big idea from a research paper way back in 1986. So today, we're going to break down that exact paper and the one algorithm that basically taught machines how to really learn. I mean, this was the fundamental question, right? It was this massive wall that early AI researchers just kept slamming into. They'd built this incredible, powerful engine, the neural network, but they were missing the key. They couldn't figure out how to turn it on. Okay, so to really get why this breakthrough was such a game changer, we first have to understand the problem they were wrestling with. So, early on, researchers had already come up with this idea of neural networks. And they're exactly what they sound like. You know, these computing systems inspired by the brain. They're made of all these little connected neuron-like units that process information. And they showed so much promise, a ton of potential. But, and this was a huge but, these early networks, which were called perceptrons, had a major limitation. They were great at simple stuff, you know, problems where the input is basically directly connected to the output, but the moment you threw something complex at them, something that needed deeper, hidden layers of thinking, they were totally stumped. They just couldn't grasp abstract concepts. And this quote from the paper itself, man, it just gets right to the heart of it. Learning gets way more interesting, but also way harder when you have these hidden units. Because think about it. If the whole network makes a mistake, how do you know which of the thousands of little connections is to blame? It's like, who do you fire? That was the core challenge, what they called the credit assignment problem. And then, in 1986, a paper comes out that offers this just incredibly elegant solution. Okay, so this is it. This is the actual paper. Learning representations by back-propagating errors. And yeah, it looks like a dense academic paper, but buried in here was an idea so powerful it was going to change everything. And that idea was a process they called backpropagation. And this quote just perfectly captures the leap they made. The whole point wasn't just about getting the right answer. It was about giving the network the power to create its own useful new features. In other words, to let those hidden layers figure out for themselves what's important, all on their own. So, how did it actually work? Well, the concept is surprisingly simple. It's all about learning from your mistakes, but in reverse. Okay, it's basically a three-step dance. First, you have the forward pass. The network takes in some information and makes a guess. Simple enough. Step 2, you measure the error. You check the guess against the right answer and see how wrong it was. But step 3, this is the magic, the backward pass. That error, that wrongness signal gets sent backwards through the entire network. And as it goes, it tells every single connection how much it messed up. Then it adjusts each one, just a tiny, tiny bit. And you do this thousands, millions of times, and the network slowly tunes itself, getting better and better. All right, let's look at one of the first tests they ran right from the paper. The puzzle was simple for us, but a total nightmare for early AI. They wanted to teach a network to look at a simple pattern of ones and zeros and just tell them, is it symmetrical? Now, this was one of those classic problems that the old school networks just could not crack. But with backpropagation, the network solved it. And the key was that middle hidden layer. Those hidden units learned to create their own internal idea, their own abstract concept of the pattern, which is what made seeing the symmetry possible. See, it wasn't just matching inputs to outputs anymore. It was actually starting to understand. But honestly, that symmetry problem was just the warm-up. The really stunning demonstration of its power, the one that made researchers' jaws drop, came from a way more complex puzzle. Okay, this is where it gets really cool. The researchers took on a much tougher challenge. They built 2 identical family trees, one with English names and one with Italian names. Then, they just fed the network a bunch of simple facts, like Christopher's father is Arthur, or Maria's mother is Francesca. And the goal was for the network to not just memorize these facts, but to learn the entire family structure, just from those little pieces of information. So what happened inside the network's brain, inside those hidden layers? Well, this is the amazing part. It wasn't just memorizing who was related to whom. No, it started to understand the structure. And here it is. This is the absolute crux of it. The network, with 0 instructions to do so, started organizing the data in a really smart way. Some of its hidden neurons started to figure out nationality. This person is English, this one's Italian. Other neurons figured out the concept of generations. These are parents, these are children.
The network was discovering the hidden structure in the data all by itself. This is called representation learning. And at the time, it was an absolute revelation. And that ability for a network to learn its own meaningful ways to represent the world, well, that changed everything.
I mean, you can draw a perfectly straight line from that 1986 paper to pretty much all the powerful AI we have today. Backpropagation is the core engine that makes deep learning possible. It's what's driving modern image recognition, speech recognition. It's what powers the huge language models and chatbots. It's even fundamental to how self-driving cars are developed. All of it. So what's the big takeaway here? The entire AI revolution was basically built on an algorithm that is designed to do one thing, learn from its mistakes. And maybe that's the lesson for us too. That sometimes the most powerful way to learn isn't about getting the right answer right away, but about really truly understanding why you got it wrong in the first place.